Hi friends, this is SANTHOSH Kumar. Welcome to my channel Sims Academy. Today we are going to learn about the very beautiful concept in our mathematics, that is trigonometry. We spell it as trigonometry. Okay? Gono angles metry measurement. That means here we are going to learn about the three angles. How do we measure the angles, or imperfect, if we want to say, we'll have the relationship between the sides and the angles in a right angle triangle. This is what we are going to learn here. Let us construct a right angle triangle. Triangle. This is a right angle triangle. Let us say ABC. This is right angle at B. As we know, the side which is opposite to the side which is opposite to right angle, in a right angle the triangle. Right angle in the sense 90 degrees. The side which is opposite to that, we say it as hypotenuse. Now, let us consider one angle, any angle, either A or C. Let us say this angle C as theta. This is the Greek letter theta. Okay? Now, actually for this angle theta, we will be having the sides, two sides which are adjacent. We'll be having two sides which are adjacent. Between them, one is our hypotenuse. That needed to be considered always. In a right angle triangle, first we need to check always the right angle first, and the side which is opposite to the right angle, that is our hypotenuse. Now, for this angle theta, this is the side which is opposite. Hence, we write this side as the side opposite to theta. And similarly, this is the side which is adjacent. As I told you, there are two adjacent sides. Between them, one is our hypotenuse, that is the side which is opposite to right angle. And the second one, this is BC, we say the side adjacent to theta. Now, let us define all the trigonometric ratios. Okay? Why did they introduce these trigonometric ratios? Actually, in the past, if you go past, we used a triangulation method for calculating the distance between the celestial objects, thereby that being slowly converted into an easiest way, that is trigonometry. Here we are given totally the 6 ratios. We say them as ratios. Okay? The 6 ratios are being given. Number 1, it is sine. Number 2, it is cosine. Number 3, it is tangent. Number 4, it is cotangent. Number 5, we have secant. And number 6, it is cosecant. We write all of them in shortcuts. Sine, suppose sine of the angle, that is sine of theta, it is written as sine theta. Cos of theta, cosine of theta is written as cos theta. And tangent of some angle like theta, we write it as tan theta. And cotangent of some angle theta, we write it as cot theta. And secant theta, cosecant theta. Okay, next. Now, what is sine theta? Generally, we define actually in any right angled triangle for a particular angle. We can take any right angle triangle. For a particular angle, let us say 30 degrees angle. The ratio of the side opposite to 30 degrees to hypotenuse is always found to be constant. Didn't get? For any angle, let us suppose we are considering an angle of 45 degrees. This is, for this 45 degrees, this is right angle, hypotenuse, this is the side opposite, and this is the side adjacent to 45 degrees. And let us say that, let us take the ratio of opposite side to adjacent side, we have taken opposite side to hypotenuse. Let us say we got some value x. Similarly, we shall consider another triangle 30 degrees. Okay, this is 90, this is right angle, hypotenuse for this opposite, and this is adjacent. Here also, when we consider the ratio opposite to hypotenuse is found to be the same x. Here we shall take the different this one. Okay, the angle must be the same, but the dimensions of these triangles might be different. But the ratio of opposite to hypotenuse for a particular angle, even I take a very big triangle where the angle is 45 degrees, this is opposite, this is hypotenuse, and this is our adjacent. If I consider the ratio of opposite to hypotenuse, even though the dimensions of this right angle triangle are different, we get the ratio as x only. Got it? That means the ratio of opposite side to angle, given angle, to hypotenuse is constant for any right angle triangle. Whether those right angle triangles have different dimensions. The dimensions of those right angle triangles might be very different. Okay? But the ratio of opposites to hypotenuse is found to be constant, and that value we say it as a sine of that angle. Got it? Okay. Now, sine theta equals to opposite side to theta by hypotenuse. What is the side that is opposite to theta? That is AB by AC. Now similarly, cos is the side adjacent to theta by hypotenuse. Here we have the side adjacent to theta, it is BC by AC. BC by AC. Okay? Here, tan is the ratio of sine to cos. It is the ratio of sine to cos. The sense opposite by hypotenuse by adjacent by hypotenuse. This hypotenuse gets cancelled in the denominator. Finally, we obtain the tan theta as opposite by adjacent. Here the opposite side to theta is AB and adjacent side to theta is BC. Next, let us move on to cotangent. Cotangent is the reciprocal of tan. In the sense, tan we have written it as sine by cos, then cot we can write it as cos by sine. Cos by sine, again reverse. Adjacent by hypotenuse, by opposite by hypotenuse. Hypotenuse gets cancelled. Finally, we are left out with adjacent by opposite, that is BC by AB. Okay, let us move on to secant theta. Secant is the reciprocal of cos. Cos we have adjacent by hypotenuse, then we write secant as hypotenuse by adjacent. Hypotenuse here we do have it as AC, by adjacent it is BC. Now finally we came to cosecant. Cosecant is the reciprocal of sine. As we have written sine theta as opposite side to theta by hypotenuse, hence we can write cosecant theta as the reciprocal of sine theta, hypotenuse by the side opposite to theta, which equals to AC by A. Now we have come across 6 trigonometric ratios. The 6 trigonometric ratios. The first one is sine, second one is cosine, third one is tan, fourth one is cotangent, fifth one is secant, and the sixth one it is cosecant. Sine of the angle opposite to theta by hypotenuse, cos of the angle adjacent to theta by hypotenuse, tan of the angle sine by cos opposite by adjacent, cot of the angle reciprocal of tan, that is adjacent to theta by opposite to theta, secant of the angle which is the reciprocal of cos. Cos is adjacent by hypotenuse. Then secant becomes hypotenuse by adjacent. And finally, it is cosecant which is reciprocal of sine. Sine is opposite by hypotenuse. Now cosecant is hypotenuse by opposite. This is about the basic concepts of trigonometry. That means for any triangle with different dimensions we can take. Any right angled triangle with different dimensions, if we take the ratio of for the same angle, I have mentioned the same angles over here. It should be the same 45, 45 or else even 30, 30, 30, 30 for different right angle triangles. If you consider the ratio of opposite to hypotenuse is constant for any kind of triangle, right angle triangle for a particular angle. The same thing holds good for all the other trigonometric ratios. Now, let us try to know the values of these. Let us try to know the values of these trigonometric ratios. As we know the Pythagorean theorem of a right angle triangle, Pythagorean theorem is the square of the hypotenuse is equal to the sum of the squares of the other two sides. Okay. Now, if we learn only one value, okay, angle 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Generally we write, we have one other thing. We need not do, just let us write all the values of sine first, then we can deduce all the other trigonometric ratios. Okay, let us see now. Sine theta, okay, sine 0 it is 0. As I know I am writing, you need to learn them compulsorily. Sine 30 it is 1 by 2. Sine 45 1 by root 2. Sine 60 root 3 by 2. And sine 90 it is 1. If you observe carefully, the first value is 0. Second value is 0.5, 1 by 2. Okay, third value it is 1 by root 2. Let us rationalize. Root 2 by root 2. That is root 2 by 2. As we know the value of root 2 is 1.414. Okay, let us take only 1.4. Then it becomes 0.7. Next, root 3 by 2. Root 3 value 1.732. Okay, let us take only 1.7. That is 2 8 is 16, 0.85. And finally sine 90 we got it as 1. When we move from 0 degrees to 90 degrees in sine, the values are getting increased. You see, sine 0 is 0 and sine 90 value is 1. From 0 degrees to 90 degrees, when we are moving, when we are increasing the angle gradually, the sine of the angle also increases. And the maximum value of sine of any angle, it is 1. But it is 1. Okay. Now let us move on to cos. Just if we write from that end to this end, that becomes our cos. Cos 0 it is 1. Cos 60 it is root 3 by 2. Cos 45 again 1 by root 2. From that end to this end I am writing cos. Okay, those are we learn how we got this when we are going to learn about the complementary angles. If sum of two angles is 90 degrees, then those two angles are called as complementary angles. Now next we have 1 by 2 and 0. That means cos 0 1, cos 30 0.85, cos 45 0.7, 0.5 and 0. The value of cos is declining as we move from 0 degrees to 90 degrees. Now let us come to tan. As I told you, tan theta is nothing but sine theta by cos theta. Let us write in detail. Tan 0 equals to sine 0 by cos 0. Sine 0 value it is 0 by cos 0 1. Hence we got the value of tan 0 as 0. 0 by something is 0. Next, tan 30 degrees, sine 30 degrees by cos 30 degrees, sine 30 degrees 1 by 2, cos 30 degrees root 3 by 2, 2 gets cancelled, 1 by root 3 is value of tan 30 degrees. Next, let us come to tan 45. Tan here, sine 45 degrees by cos 45 degrees. 1 by 2 by 1 by 2 both gets cancelled. We got the value as 1. Tan 45 1. Okay, let us fill them. 0, 1 by root 3, 1. Tan 60 degrees equals to sine 60 degrees by cos 60 degrees. Root 3 by 2 is the value of sine 60. Cos 60 it is 1 by 2. 2 gets cancelled. Root 3 by 1 it is root 3. Now coming to tan 90. Tan 90 value sine 90 by cos 90. Sine 90 it is 1 but cos 90 it is 0. Something by 0 undefined, or we say it as infinity. Okay? Let us write it as infinity. We have deduced all the values of tan. Next, let us move on to cot. Cot is the reciprocal of tan, as we discussed. Cot 0, here we shall write cot 0 equals to 1 by tan 0, tan 0 0, 1 by 0 it is infinity. Cot 30, 1 by tan 30, 1 by root 3, it is root 3. Next, cot 45, 1 by tan 45, 1 by 1 is always 1. 1 is there, in 1 we are taking 1. Finally we will get 1 only. Next, cot 60, 1 by tan 60, 1 by root 3, and finally cot 90. Cot 90 equals to 1 by tan 90, 1 by infinity, which can be written as 0. Similarly, secant. Secant is a reciprocal of cos. 1 by 1, 1. Just make it inverted. 2 by root 3, root 2, 2, 1 by 0, it is infinity. Coming to cosecant. Cosecant is a reciprocal of sine. Cosecant is the reciprocal of sine. In the sense 1 by 0, it is infinity. Reciprocal 2, root 2, 2 by root 3, and 1 by 1, again it is always 1. This is the trigonometric table where we will be given the numericals related to these values. If we learn to write this table perfectly, then we could solve 25% of the problems in trigonometry, especially for the 10th standard. Now, finally we came to understand sine, it is opposite by hypotenuse, cos, adjacent by hypotenuse, tan, sine by cos, opposite by adjacent, cot, 1 by tan, adjacent by opposite, secant, 1 by cos, adjacent by hypotenuse. Cosecant 1 by sine, hypotenuse by opposite. Okay. We got the values as well. Now, let us move onto the identities. What are identities? We have an identity card when we go for a job. Similarly, for these trigonometric ratios also, they have their own identities. Before going for the identities, we discussed the cosecant is the reciprocal of sine. In the sense, I can write sine theta into cosecant theta equals to 1. Similarly, secant is the reciprocal of cos, hence I can write cos theta into secant theta equals to 1. Next, cotangent is the reciprocal of tan, hence we can write tan theta into cot theta equals to 1. Now, let us move on to the trigonometric identities. Let us consider a triangle A, B, C, right angle at B. Let us say now we shall go like this. This is theta. Firstly, we have taken this as theta. Now let us move on to with A. First of all, we need to identify the hypotenuse, the side which is opposite to right angle. In a right angled triangle is called as hypotenuse. This is our hypotenuse. Now, the side BC is directly opposite to theta. Hence, we mention it as the side opposite to theta, and AB, it is beside. Okay? Beside in the sense, we cannot write beside in mathematical language. Hence, we mention it as adjacent, side adjacent to theta. Okay? As we mentioned previously, I'll take them off. As we mentioned previously, sine theta equals to opposite side to theta by hypotenuse. Opposite side to theta, here we have it as BC by AC. Similarly, cos theta, we define it as adjacent to theta by hypotenuse. The side adjacent to theta, here it is AB by AC. Now, we shall move back to our Pythagorean theorem. What does the Pythagorean theorem says? The square of hypotenuse is equal to the sum of the squares of the other two sides here. What are the other two sides here? AC square can be written as AB, BC square plus AB square. Let us keep this one in our mind first. Now, first identity, sine square theta plus cos square theta. Sine square theta, it is BC square by AC square plus AB square by AC square. BC square plus we should take the LCM as AC square. BC square plus AB square. BC square plus AB square is nothing but our AC square. That is finally AC square by AC square, we got it as 1. We obtained finally sine square theta plus cos square theta equals to 1. This is our very first identity. Let us move on to the second one. What is secant theta? It is the reciprocal of cos theta, as we know, AC by AB. Similarly, tan theta, opposite by adjacent, BC by AB. Now, secant square theta, let us find, minus tan square theta. Secant square theta, AC square by AB square, minus tan square theta, BC square by AB square. LCM is AB square, AC square minus BC square. If we transpose this BC square to this side, then AC square minus BC square becomes AB square by AB square, which is equals to 1. That means second identity we obtained it as secant square theta minus tan square theta equals to 1. This is our second identity. Let us move on to the third one. Cosecant theta is the reciprocal of sine theta. Sine theta is BC by AC. Then we write cosecant as AC by BC. Similarly, cot theta is the reciprocal of tan theta, AB by BC. Now, cosecant square theta minus cot square theta equals to AC square by BC square minus AB square by BC square. If we take the LCM, BC square, we do get AC square minus AB square. You see here, instead of sending BC square, if I send AB square, AC square minus AB square, again it becomes our BC square. BC square by BC square, it is 1. Hence, we got the third identity, cosecant square theta minus cot square theta equals to 1. Cosecant square theta minus cot square theta equals to 1. We have not yet completed. We came to know that there are 3 identities. Number 1, sine square theta plus cos square theta equals to 1. Number 2, secant square theta minus tan square theta equals to 1. And number 3, cosecant square theta minus cot square theta equals to 1. Okay. What should we learn? Finally, if we learn these 3 identities, is it enough? Is it enough? No, not at all. We have to learn like this. As we know, the first identity is sine square theta plus cos square theta equals to 1. Sine square theta equals to 1 minus cos square theta, or sine theta equals to under root of 1 minus cos square theta. Finally, I obtained the value of sine in terms of cos. If I want to have the cos in terms of sine, let us transpose the sine square to that side. Cos square theta equals to 1 minus sine square theta. Cos theta equals to under root of 1 minus sine square theta. Second one. What is our second one? Secant square theta minus tan square theta equals to 1. Let us send this minus tan square theta to that side. Then we get secant square theta equals to 1 plus tan square theta. If I send this square to that side, then it becomes under root of 1 plus tan square theta. Now I obtained the value of secant in terms of tan by using the secant. Now I wanted to have the value of tan in terms of secant. Let us have it. Let us transpose this minus tan. Okay, we shall do one thing. 1 to this side and tan square to that side. Then we get tan square theta equals to secant square theta minus 1. Tan theta equals to root over secant square theta minus 1. That's it about our second identity. Coming to the third one. Beautiful third one. Cosecant square theta minus cot square theta equals to 1. Now, cosecant square theta equals to 1 plus cot square theta. If I send square to that side, it becomes square root. Cosecant theta equals to under root of 1 plus cot square theta. I obtained the value of cosecant in terms of cot. Let us have the cot to be taken towards the LHS. Cot square theta equals to cosecant square theta minus 1, or the value of cot theta is under root of root is going somewhere. Under root of cosecant square theta minus 1. Finally, we came to know about trigonometry, which is a very important branch of mathematics. We came to understand about the ratios. We have totally 6 ratios here. Sine, opposite by hypotenuse. Cos, adjacent by hypotenuse. Tan, sine by cos, opposite by adjacent. Cot, reciprocal of tan. Cos by sine. Cos by sine in the sense adjacent by opposite. Next we have secant theta. Secant is a reciprocal of cos. Cos is adjacent by hypotenuse. Secant is hypotenuse by adjacent. Next we have cosecant. Cosecant is the reciprocal of sine. Sine is opposite by hypotenuse. Hypotenuse is the side which is opposite to right angle in a right angle triangle. Right angle triangle. Nice rhyming. Okay. Now, finally, cosecant theta equals to hypotenuse by the side opposite to theta. After that, we have learned about the values of sine, all the trigonometric ratios for 0, 30, 45, 60 and 90. Sine 0, 0, sine 30, 1 by 2, sine 45, 1 by root 2, sine 60, root 3 by 2, sine 91. If we come from class to first, cos, tan, sine by cos, tan 0, 0, tan 31 by root 3, tan 45, 1, tan 60, root 3, tan 90, infinity. Okay? When we go on to the reciprocals, we obtain the other values also. And after that, we've seen about the identities. We have 3 identities. if we learn only just sine square plus cos square 1, secant square minus tan square 1, cosecant square minus cot square 1, it's not enough for solving the numericals. Hence, we need to learn the value of sine in terms of cos in terms of sine, secant in terms of tan in terms of secant, cosecant in terms of cot in terms of cosecant. How we have written, that is sine square theta plus cos square theta equals to 1, sine square theta equals to 1 minus cos square theta, sine theta equals to under root of 1 minus cos square theta. Cos square theta equals to 1 minus sine square theta, and cos theta equals to under root of 1 minus sine square theta. Second one, secant square theta minus tan square theta equals to 1. Secant square theta equals to 1 plus tan square theta. Secant theta is under root of 1 plus tan square theta. And tan square theta equals to secant square theta minus 1. Tan theta equals to square, send that side, it becomes a big square root. Tan theta equals to under root of secant square theta minus 1, which I have written over here. And the last and final one, as I told you, it is cosecant square theta minus cot square theta equals to 1. Cosecant square theta equals to 1 plus cot square theta. Cosecant theta equals to under root of 1 plus cot square theta, or cot square theta equals to cosecant square theta minus 1, and cot theta equals to under root of cosecant square theta minus 1. Hope you enjoyed the basic concepts of trigonometry. Then we are going to have the numericals based on the different values of sine, cos, and the numericals based on the identities, etc. And later we move on to the applications of trigonometry in terms of heights and distances. And this is Santhosh Kumar from Sims Academy signing out. Bye bye.